Hi everyone. My name is Faizan, and we'll get started with today's session. The session is to be on this topic called quadratic equations. Okay, so quadratic equations, as you know, is a very useful topic. In different exams, it appears regularly, and this is going to be a 20-25 minute session where I will walk you through how you should approach studying quadratic equations. Okay, so let's get started. The first idea that I want to introduce you with is the idea of variable. Okay, uh, you'll always encounter variables x, y in algebra, and quadratic equations also will deal with such variables. Now, first of all, understand that when I write fx is equal to ax square plus bx plus c, this, my friends, is a quadratic expression. Okay. Now, don't confuse that a, b, c, and a, b, c are not variables. All of a, b, c are actually constants. The only variable that you see over here is x. Okay. The only variable that you see over here is x. A, B, C are constants. Now, further to that, within a quadratic equation, you notice that the highest power of x is 2. What does that indicate? That means for a function to be a quadratic equation, the variable that is defined in that function, that variable's highest power or exponent cannot be more than 2. Okay, and it also cannot be less than 2, otherwise it will not be a quadratic, it will become something else. So first things that we need to understand is this x square is mandatory, or it's required for it to be a quadratic equation. Okay, now f x square, what we have understood is that x square is a mandatory thing for it to be a quadratic equation. Is the other term, which is x, also mandatory? Any ideas? Yeah, so the answer is the other term, which is x, is not mandatory. The other term, which is with the coefficient b, may or may not be there in a quadratic equation. The equations but requires it to have a power of x with a degree of 2. So you might have something like x square plus simply a constant 5, right? Here, this 5 is what c would mean, okay? And if you do not find anything, that means it is 1, and this is what A would resemble. Now, the question that I would ask you is, what is the value of B? And you should answer that the value of B is equal to 0, because you do not see that term with X. That term that is required, that which is the second term, that second term seems to be missing. And therefore, what we can safely say is that second term is missing, and therefore the value the this equation, the variable x to the power 1, that term is missing, which means it is x to the power 1, but b is equals to 0. Okay, so these are some of the ideas with respect to understanding what I wrote in the beginning, which is fx is equal to ax square plus bx plus c. So fx is equal to ax square plus bx plus c. You need to understand very carefully what a means, what is the importance of this term, what b and c, what values they can take. I want to ask you one more question. Can a, b, c be negative numbers? Can I have something like a is equal to -2, b is equal to -4, and so on? Okay, think for a moment. In fact, I can also ask you, can a be something like a fraction, 2 by 5? Is that possible in a quadratic equation? Will it still remain a quadratic equation, or will it cease to be a quadratic equation? Okay, so just think for a moment. Go back to the very basic thing that I told you in the first part, in the beginning, basically, as to what is the thing that is required for it to be quadratic. This is what is mandatory. Okay, x square. The moment you have x square, whatever coefficients are, whether it is negative or it is not negative, it is not so important. But for it to have x square, which is the power of 2, is a very important requirement for it to be a quadratic equation. Okay. All right. So now that we have understood what quadratic equations basic general term is, let us understand one more idea about quadratic equation. And this idea is something that is useful when dealing with polynomials in general. Okay, so firstly, let me write something like a quadratic equation x squared plus 5x plus 6. The first question that I'm going to ask you is, do you think this is a quadratic equation? Do you think this is a quadratic equation? So the answer is yes, because it has the term x squared. Okay. Now, what I will do is I'm trying to represent this quadratic equation as two factors, factors as in something like, x plus alpha into x plus beta. Okay, in this format. In fact, it would be useful for you to, for now, you can relate it instead of writing alpha, maybe I can write a and b. So what I mean is, if I write something like x plus a constant, right? Let me put a number, x plus 2. So this is one factor. Now, when you multiply it with another factor, let me put a number with x. This is another factor. Now, notice carefully. If you want to expand this, for those who forgot expansion, you take the first term, which is x to the power 1. This means x to the power 1. Take the first term, then you multiply with both the terms. Similarly, you take the second term and then you multiply with both the terms. Okay. Now just try to solve this and see if it equates to the original question or not. Just try and solve this and see if it equates to the original question or not. The answer is yes. It does. It does tend to equate to the original question, which means that your the way you wrote the factors x plus 2 into x plus 3 is actually right. And now you can see that I can convert any quadratic expression into two factors, right? Okay, two things here. First thing is, see in the two factors that I converted, the power of x is actually 1. Yeah, the reason why it is 1 is because when x will get multiplied with x, you will get a power of 2, which is important for a quadratic. And why we have 2 and 3 is something that we will see further. But for now, you can observe the question itself and hopefully you'll get the answer. Okay. Now, what I want you to understand is the idea that you can actually split a middle term. Okay. There's something called as the middle term splitting. There's something called as the middle term splitting. What is the middle term? So the middle term in a quadratic denotes the term with the power of x is equal to the power 1. This this part where x variable is with the power of 1 is what is the middle term. So let's see what is that term in this question. So it happens to be 5x. That is your middle term. Now, what you can actually do is you can convert the middle term into two parts, or basically you can just break it. If you have 5 rupees, if you have 50 rupees, you have, let's say, two notes of 30 rupees and 20 rupees. The idea is that these two will together add up or subtraction, that those are two, either addition or subtraction, and has to make up the middle term. Now, in this case, if I make plus 3x and plus 2x, what I do end up getting is a plus 5x, which means I end up getting the middle term, which means this should be right. Now, there's one more logic as to why I did 3x and 2x. Can you try and check as to what is the importance of doing converting breaking 5x into 3x and 2x? Yeah, this has to do something with factors. That's the hint. This has to do with something with factors. Okay. Now, if you had split here 5x into 3x and 2x, right? So how will that look like? It will look like x square. Let me erase this. So if I had done what I just said, which is break it into two parts, x square, 5x has 3x and 2x, what you get is x square plus 3x plus, yes, plus 2x and then plus 6. Now look at what is common in the first two terms. X is common in the first two terms. So you take x here, x plus 3. Now whatever you have in the bracket, just try and replicate this in the other part. If you notice right now you are having four terms and the first two terms have already been converted into this format. Which means if you want to replicate this, why don't you do a plus 2 outside the bracket so that when you solve this should give you 2x plus 6. And now, if you notice, x plus 3 is something which is constant across this first term and this second term. So why don't you take it outside? And then you want to end up getting is x plus 3, which is the common part, into x plus 2. This is what I initially wrote. Okay, this is the same as what I initially wrote about splitting the middle term. Okay, so this is a very important idea, and I'll give you one or couple of more cases about splitting of middle term so that you get very comfortable with this idea about splitting of middle term. Okay, now this was a very simple example where I split 5x into two parts, which was 3x and 2x. Okay, it may not always be the same. At times, you will notice that the splitting of the middle term would mean that you have to have one term as positive and one term as negative. Okay, so suppose this is the question. Now, what I've just written is x square minus 2x minus 8 is equals to 0. I've added an equal to sign, which means this now becomes a quadratic equation. Now, the only reason why it is an equation is because I've added an equal to sign. Let's see. The idea about the middle term is that you give into two parts, split into two parts, such that upon addition you get the middle term, but upon multiplication you get the constant term. I repeat, on addition you get the middle term, but on multiplication, which is multiplication, I mean multiplication of coefficients, minus 4 into plus 2, the coefficients part. So on multiplication of the coefficients part, you get a this term. But remember, this only holds true when a is equal to 1. So if you find an equation, quadratic equation where a is not equal to 1, first try and convert that into 1. And that is very easy to do. Just multiply it by whatever is the a. So if a is 2, divide by 2 all the terms. If a is 3, divide all the terms by 3. If a is 4, divide all the terms by 4. That is how you can get a is equals to 1. Now, the moment you get a is equals to 1, right, that means this will now apply. The middle term, which is minus 4x and plus 2x, will give you a middle term. And the coefficients of the middle of the breaking of middle term is minus 4 and plus 2, which will multiply will give you a minus 8. So now it looks perfect for me. So why don't we just try and see how it looks like? This becomes x square minus 4x plus 2x minus 8 is equals to 0. Now, what I just did before this example was I took the first two terms and I took whatever was the common part. So if I look at the common part here, the common part here happens to be x. And if I want to take out if I want to take out x such that the two terms are x square minus 4x, then it will be x minus. And remember, this is only about the first two terms. You have to have the x minus 4 in the third and fourth term also. Now, now I should multiply with a 2 so that I get 2 into x, and 2 into minus 4 is minus 8, which means what? X into x minus plus 2 into x minus 4, which means now it can be written as x minus 4. Okay. So what I've just done is that I've converted this x square minus 4x plus 2x minus 8 as x minus 4 into x plus 2. right? And which means that this quadratic equation has now been converted into two factors. The two factors are x minus 4 is the first factor, the second factor is x plus 2. Now, if you remember, the question was not just about this expression. We also had one important part which is equals to 0. What does that indicate? When you multiply two quantities and the result is equals to 0, what can we say about one of the quantities? See, if you're multiplying 5 into 0, you have to get a 0. So whenever there are two things getting multiplied and the result is 0, one of them must be 0, which means for here, x would be equal to 4 or x would be equal to minus 2, right? And this introduces to us the concept of roots in a quadratic equation. I repeat, this introduces to us the concept of roots in a quadratic equation. Now, what is roots? Roots are the values of x, which when you substitute in the quadratic equation, the entire equation becomes equals to 0. I repeat, roots are those values of x, which when you substitute in the quadratic equation, the entire quadratic equation will become equal to 0, right? And this is also something that is that is very common and very important part of the equation. So you have something that is known as roots, and roots are nothing but when you substitute in a quadratic equation, the expression, the quadratic expression is equals to 0. Okay. Now, for the two examples that I did, it was the process that I followed was that I tried to convert them into factors first and then equate it to 0, and I got the answer directly. It may not always be possible for me to be able to convert them into factors, because at times you may deal with numbers which are not possible to split the middle term. Suppose I give you x square plus 9x plus 20. Okay. Do you think I can split the middle term? Yes, I can. I can still write it x square plus 5x plus 4x plus 20. And therefore I get x into x plus 5, x plus 5 here and plus 4 here, which means I get two factors, which is x plus 4 and x plus 5. Now the next question would be, what do you think are the roots of this quadratic equation? So logically, it comes out that the roots of the quadratic equation are x is equals to minus 4. Yes, because the moment you put x equals to minus 4 in this expression, the entire expression tends to be equal to 0. The same also is true when you put x equals to minus 5. The moment you put x equals to minus 5, the entire expression tends to be equal to 0. So I can say that these definitely are the roots of the equation. But if it was because it was very convenient, the middle term here, the middle term here and the constant term here was quite easy to convert, and therefore I could get the roots. Okay. Now I'll give you one more example where I will try to introduce you to the idea of a formula-based approach to finding roots. So let's just take the same example with a small difference. Notice that I've changed the number 20 to 18, which means at this point, I can still do x square plus 6x plus 3x plus 18, which means I can still factorize. Okay. But the moment I do x square plus 9x plus 15 is equals to 0, I think for this question, splitting the middle term will be slightly difficult. Okay, because you have to follow the both the conditions. Whatever the coefficients that you split in should multiply to give you 15, which is not true in this case. For such questions going forward, we introduce the idea about finding roots through a formula based approach. So let's see what is the formula based approach to finding roots. Okay, so for x to be a root, this must be equal to minus b plus minus b square minus 4ac by 2a. Now, what are these a, b, c? Go back to the initial part where I wrote the general term of a quadratic equation, which is ax squared plus bx plus c. This was basically the general term of a quadratic equation. And I discussed about this general term at the at the towards the beginning of the class. So this BAC is taken from the general term, which means if you get an equation, you first try and find out what are the values of A, B, and C by comparing it to this standard form. So in this example, the value of A happens to be 1, the value of B happens to be 9, and the value of C happens to be 15. If you input this into this question, what you end up getting is basically the values of X. Okay, now what is this sign plus minus? This indicates that the values of X are not 1 but are 2. Okay, I repeat, this indicates the values of X are not 1 but 2. Okay, one more idea. If you look at this part is a square root of something of b square minus 4ac. Now, for a square root, if you remember, root over x is defined only when x is more than equal to 0. I mean, don't confuse this x with the one in quadratic. Anything that is inside a square root, I've called it as x, okay? Anything that is inside a square root. So in this case, it is something else. The thing which is inside the square root must be greater than or equal to 0 for it the square root of x to be defined. That is what I'm talking about, right? Whatever is inside the square root, for that to be defined, the for whatever is inside should be equal to greater than equal to 0. Now let's see what is the application of that in this question. So what I typically mean by that is, so I have b square minus 4ac, which is inside the bracket. Now this should be greater than equal to 0. And why do you think this is required to be greater than equal to 0? There is a very interesting logical answer to that. See, if this is not equal to 0, then what happens is that you end up with something like root over minus 80. You end up something with root over minus 4. All these do not have any real number value, right? You will go into a different topic, which is imaginary numbers. So these are not defined in real numbers. And therefore, it is very important that whatever is inside of the square root has to be greater than or equal to 0. So the moment I do b square minus 4ac is greater than or equal to 0, what does that indicate? It indicates that this condition, if it holds true, you will end up getting a real value for x. And further, if you have something like this, you will end up getting x has only one repetitive value. If you have something like b square minus 4ac is more than 0, x has two real values. Okay. So what do we understand from here? We understand that whatever is inside the bracket in this equation is important to know what are the nature of x. So if this is greater than 0, x will have two real values. If this is not greater than 0 but just equal to 0, it will have one repetitive value. Okay, why it has two real values is because one time you will do a plus something and the other time you will do a minus something. But in case of 0, you do a plus 0 or you do a minus 0, that does not change the value of x. And that's the reason why you get one value which is repeating. Okay. All right. So we have understood the idea about roots. Let's understand let's understand how do we apply this in different cases. Okay. So there are a bunch of questions where you can apply this. Uh, let's see from the very first example. Okay. So what I've got in front of you is you have an equation x squared plus 7x plus 8 is equals to 0. Find out the nature of x. Okay. So if I go and go to the very formula first, what I get is x is equals to minus b plus minus b square minus 4ac by 2a. Now compare this equation x square plus 7x plus 8 with the general format ax square plus bx plus c. Here you will end up getting a minus 7. B square will therefore be 49 minus 4 into 1 into 8. What I've done is I've just taken the values of A and the values of C from this expression upon 2 into 1. Now what is 41 minus 4 into 8? It is nothing but minus 7 plus minus 49 minus 32 upon 2, which is nothing but minus 7 plus minus root over 17 upon 2. Now, in this case, it so happens that this b square minus 4ac happens to be more than 0. Okay, which means it will have a definite value, and the value is root over 17. When this root over 17 is further solved with this remaining numbers, you get two values of x, because minus 7 plus and then minus 7 minus, which indicates that what you have essentially is that the nature of x is real. There are two different values of x, and those numbers are real numbers. The two numbers which are of x are real numbers. Okay. And you can apply this in several use cases wherever you have not able to split the middle term, you can apply it in all of those scenarios. So we'll now move into something else. The idea about this would be that we will try and understand what happens in cases where it looks like a question of not quadratic, but it is actually quadratic. Okay, so let's see something like if you have x square plus 1 by x square. Okay, do you think this also is quadratic in nature? That's the first question. Second question would be if you have y to the power 4 plus 2y square plus 8 is equals to 0. Okay. Can we use quadratic to solve this question? Can we use quadratic to solve this question? And what do you think how you can solve the question? So let's see that. First question, x square plus 1 by x square. So x square plus 1 by x square is basically also taught in something else, which is about AP and GP. I can rewrite this as x minus 1 by x whole square plus 2. Okay. If I remember the formula for a minus b whole square, this will really be applicable over here. A minus b whole square is a square plus b square minus 2ab. So the moment you do that over here, you get this term. Now, anything that is under square, which what I'm saying is anything like y square, z square, the minimum value for all of that is always greater than equal to 0. You take any number and you square it, it will never be equal to, it has to be either equal to 0 or it will be more than 0. Suppose you take a minus 2 and then you square it, you get a 4. Suppose you take a 0.5 and you square it, you get a 0.25. Of course, if you take a 0, you end up getting 0. But otherwise, whatever number you take and then you square it, it has to be more than equal to 0. That's the idea about squaring of terms, which means this part must be more than equal to 0, which in turn means that this question tells me this entire expression must be more than equal to 0. Okay. So it's not a direct example of what we are doing, but it just came to my mind that this expression frequently you will see questions around this. And a minus b whole square, which is a part of quadratic, is something that can be used to understand the value of x square plus 1 by x square. Okay, let's go to the more relevant question, which was about, yeah, the question looked like this. The question tells me that y square plus 8y square plus, let's say, 10 is equals to 0. Now, in this case, if you compare this with the general term of quadratic equation, it is not a quadratic equation. But if you think of y square is equals to x, you can actually write this as x square plus 8x plus 10 is equals to 0, right? Just have a look, very careful look at what I have just done. If you look at y to the power 4 plus 8y square plus 10 is equal to 0, this is not a quadratic. But if you try and substitute y square is equal to x, then what ends up happening is you get this as x square, because y to the power 4 will be what, x square, plus 8 into x plus 10 is equals to 0. Now this is a quadratic equation. This is a quadratic equation, which means whatever we have learned about quadratic equation, about splitting the middle term or finding the zeros of the quadratic equation, all of that should actually hold true. Okay. I repeat, whatever you have learned about quadratic equations, about the constants, constant b, about splitting the middle term, constant term, finding the, whatever you have learned, finding the zeros, because all of that should be useful. Okay, let's use the formula in this case and see what is the value of x that we are getting. So if you use the formula of x, x is equals to minus b plus minus b square minus 4ac by 2a. Okay, what is this? What does x look like? It looks like minus b plus minus root over b square minus 4ac by 2a. If you want to substitute, what you end up getting is minus 8 plus minus 64 minus 4 into 10 upon 2. Okay. What I've just done is that I've taken the value of b from the expression, which comes out to be 8 here. I've taken the value of a from the expression, which comes out to be 1 over here. I've taken the value of c from the expression, which comes out to be 10 over here. And what I end up getting is minus 8 plus minus root over 24 upon 2. So what I've got is minus 8 plus minus root over 24 upon 2. Now, what is root over 24? It will be like between 4 and 5. How I can say that? We know the square root of 25 is 5, which means that now you can go on and solve. You will get the values of x. Uh, you will get the values of x and you will understand that both the values of x are real numbers. And in fact, both the values of x happens to be negative real numbers. Okay. Why do you think I told negative real numbers? Why do you think I told negative real numbers, that both the values of x are negative real numbers? Have a look and have a try and solve this. You will get the answer. Okay. All right, so I think this should be enough for today's session. I look forward with a second part to this quadratic equations lecture series, and I hope you understand. If you have any questions, please feel free to write in the comments. Thank you for watching. See you again.